Hello everyone, this is Scan City Academy. In today's lesson, we are going to discuss factors and prime numbers. What are factors? Factors are any pair of natural numbers you can multiply to get another number. For example, 3 and 6 are factors of 18 because 3 times 6 is equal to 18. However, these are not the only factors of 18. The complete collection of factors of 18 is 1, 2, 3, 6, 9, and 18 itself. This is because 1 times 18 is equal to 18, 2 times 9 is equal to 18, and 3 times 6 is also equal to 18. These are called the factors, and 18 is the product. Now let's solve some examples. So let's say we want to find the complete set of factors for 12. Let's start from 1. And of course, 1 is a factor of every number because any number is divisible by 1. So 1 times what number is equal to 12? 1 times 12 is equal to 12. Don't forget that whenever you want to find the complete set of factors for a particular number, 1 is always the lowest factor and the number is always the highest factor. In this case, we want to find the complete set of factors for 12. So 12 is the highest factor and 1 is the lowest factor. Now let's move to 2. 2 times what number is equal to 12? Realize that 2 times 6 is equal to 12. Now let's move to 3. Is 12 divisible by 3? 3 times what number gives 12? 3 times 4 is equal to 12. So these are the set of factors for 12. In each step, we have 2 factors. In the first step, we had 1 and 12. In the second step, we had 2 and 6. And in the third step, we had 3 and 4. So the complete set of factors for 12 is 1, 2, 3, 4, 6, and 12 itself. Now, when you do this very well, you realize that whenever you multiply the outer numbers, you are going to get 12. So 1 multiplied by 12 is equal to 12. 2 multiplied by 6 is equal to 12. And then 3 multiplied by 4 is also equal to 12. Now let's try another example. So let's say we want to find the complete set of factors for 25. Now let's start from 1. 1 times what number is equal to 25? 1 times 25 is equal to 25. Let's move to 2. Is 25 divisible by 2? 2 times 11 is equal to 22. 2 times 12 is 24. And then 2 times 13 is equal to 26. So obviously 2 times no number is equal to 25. So 2 cannot be a factor of 25. What about 3? 3 times 8 is equal to 24. And then 3 times 9 is equal to 27. So 3 times no number can give you 25. Same applies to 4. However, 5 times 5 is equal to 25. So 5 is a factor of 25. Now the complete set of factors for 25 is 1, 5, and then 25. Let's confirm our answer by multiplying the outer numbers. So 1 times 25 is equal to 25. And then 5 times 5 is equal to 25. So the complete factors of 25 are 1, 5, and then 25. I forgot to mention this, but in the case where we have the same number multiplying itself to give a product, then you need to write only one of the numbers here. So let's say in this case we have 5 multiplying 5 to give 25. However, writing the complete set of factors for 25, we are just going to write only one 5. So when you have something like this, it means that 5 times itself is equal to 25. I hope you get it. Let's solve a more complex example. So let's say we want to find the complete set of factors for 72. Now let's start from 1. 1 times 72 is equal to 72. What about 2? Is 72 divisible by 2? Yes, because 72 is an even number, and every even number is divisible by 2. So let's say we have 72 divided by 2. 2 goes into itself once, and then 2 goes into 7 3 times, remainder 1, making 12. 2 goes into 12 6 times. So 2 times 36 is equal to 72. Let's say we have 72 divided by 3. 3 goes into itself once, and then 3 goes into 7 2 times, remainder 1, making 12. 3 goes into 12 4 times. So 3 times 24 is equal to 72. So 3 is a factor of 72. Now let's say we have 72 divided by 4. Is 4 a factor of 72? Let's see. 4 goes into itself once. 4 goes into 7 only once, remainder 3, making 32. 4 times 8 is equal to 32. So 4 is a factor of 72. That is 4 times 18 is equal to 72. How about 5? 5 times 14 is equal to 70. And 5 times 15 is equal to 75. So 5 cannot be a factor of 72. 6 times 10 is equal to 60. 6 times 11 is equal to 66. And then 6 times 12 is equal to 72. So 6 is a factor of 72. 6 times 12 is equal to 72. 7 times 10 is equal to 70. And then 7 times 11 is equal to 77. So 7 cannot be a factor of 72. Now let's move to 8. 8 times 8 is equal to 64. And then 8 times 9 is equal to 72. So both 8 and 9 are factors of 72. 8 times 9 is equal to 72. So these are the factors of 72. Now let's list them. We have 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. So these are the complete set of factors for 72. Now let's talk about prime numbers. What are prime numbers? Prime numbers are numbers that has only two factors, itself and 1. Examples of prime numbers are 2, 3, 5, 7, and 11. Notice that 1 is not a prime number because it has only one factor, that is itself. Now, let's try to find the set of prime numbers between 1 and 30. To do this, let's first of all list the set of natural numbers from 1 to 30. Now, the rule is to cancel out 1 because 1 is not a prime number. It has only one factor, that is itself. Now, we are going to circle the next number after 1. So the next number after 1 is 2. So we are going to circle out 2. Now, after circling out 2, we need to cancel out all multiples of 2. So multiples of 2 are 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. Now, the next step is to circle the next number. So the next number after 2 is 3. So we are going to circle out 3 and cancel out all multiples of 3. So multiples of 3 are 6, 9, 12, 15, 18, 21, 24, 27, and 30. 4 has been cancelled out, so we need to move to 5. Now we are going to circle out 5 and then cancel out all multiples of 5. So multiples of 5 are 10, 15, 20, 25, and then 30. The next number after 5 is 6. However, 6 has been cancelled out. So we need to circle the next number after 6, which is 7. And then cancel out all multiples of 7. Now multiples of 7 are 14, 21, and then 28. The next number after 7 is 8. However, 8 has been cancelled out. Aside from 8, 9 has also been cancelled out. 10 has also been cancelled out. So the next number we need to circle is 11. Now multiples of 11 are 22. The next number after 11 is 12. However, 12 has been cancelled out. So we need to circle 13. And then multiples of 13 is 26. So after cancelling out 26, then we are going to circle out 17 because 17 has not been cancelled out. So multiples of 17 are 34, 51, and the like. However, they cannot be found within this range. So we need to move ahead to circle the next uncancelled number, that is 19. And then multiples of 19 are 38 and so forth. However, 38 is not in this range. So we need to move ahead and then circle the next uncancelled number, that is 23. And then the next uncancelled number is 29. So the set of prime numbers between 1 and 30 is 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So these are the sets of prime numbers between 1 and. However, you can use this approach to find the set of prime numbers between any two numbers. So that's it for this video. I hope you enjoyed it. If you like the content of this video, feel free to like, comment, and share among friends. Don't forget to subscribe to our channel to receive more interesting videos. Hope to see you in my next video. Bye bye.